utility room. This is where all the controls are. We're going to walk into the where the electronics are first. Okay, what you're looking at right now is the temperature display on the solar beam control box, which we'll show you a big picture of in just a second. The first one is called the heat sink. That's the absorber or the collector, the 10-inch by 10-inch collector where all the sun is focused to. With the water circulating through that, it's now reading, if I can see it from here, 89. Let me see if I can see that. Yeah, 89.73. That is in centigrade. That is the temperature up at the absorber, not the high heat I was telling you about of 1200 degrees. That's the temperature of the box with the water cooling it. The next one is called the hot. That is the hot water coming out of that absorber. It says here 71.9 degrees Celsius. And this has been on for about 2 or 3 hours. By another 2 or 3 hours from now, that'll be up to about 80 or 90 degrees Celsius. The cool is the water that is coming in from the home, and that is at 58 or 56.4. You can see the delta T in this case is about from 56 to 71 is around 14 degrees. And oh, the light just went out. Let me put that back on. And that's the change in temperature out at the absorber. And now we're going to take a look at the rest of the system. This box right here is what is known as a UPS backup. It's a battery backup. What that means is it's very important that the solar beam track the sun from sunrise to sunset. And in the event of a power outage, we wouldn't want it to lose its tracking and then have to wait, for it to retract. So this battery backup will handle up to 6 hours if there's no electricity for the solar beam to continue to track. And it's automatic, and if the power went out, you would never know it. I also have a full automated generator for the entire house that would also kick in, but this is a little bit more immediate because that one takes. There are several safety devices in the solar beam to prevent any type of overload or overheating. Right up in this area, this right here is a pressure switch. And if the pressure in the solar loop of the water that's going to and from the solar dish ever goes below a certain pressure, and I think it's set at 6 pounds, the solar beam will turn off. This is known as a pressure switch. We also have temperature sensors throughout the solar beam, so if the heat ever goes over a certain preset temperature, the solar beam will again shut off. There are many safety devices to prevent any type of overheating occurrence. At the very bottom, this is known as an expansion tank. All systems have expansion tanks to allow for the changes in thermal temperature in the system. Above this is what is known as a pump station, and I'll take the cover off so you can see what it looks like inside. In this system we have 2 pumps. Again, this is all traditional. It's not unique to the solar beam. It's used in every type of solar thermal system if they decide to use a pump station. I explained what the temperature difference was going to and from the solar beam. It's 125 degrees it shows right here of the temperature going out there. The returning temperatures, as evidenced by this temperature gauge, is 150 degrees, and I'm giving everything in Fahrenheit because most people in America understand Fahrenheit. This other loop right here, there's a heat exchanger built into this pump station, and the heat exchanger extracts the heat from that's being created outside and stores it in the various tanks that I have in the home. As you can see by this, the temperature of the water that's coming in is 125 degrees. If I read that correctly, I'm sorry, 115 degrees. And the temperature after it goes through the heat exchanger, it comes through this pipe, and it's about 138 degrees. So we're picking up about 22 degrees on that alone, right in this area. By the end of today, if I could show you at 5 o'clock today, if the sun continued to shine, these temperatures would probably be at about 180 and approaching possibly 200 degrees in one day. The unit outside will produce up to 42,000 BTUs per hour of thermal energy. Right now, I haven't done a calculation, it's probably doing about 32,000. It depends on how clear the atmosphere is and whether there's clouds and that. but the ultimate is about 42,000 BTUs per hour, and I've seen about 36,000 the other day. Now we're going to take a look and show you some of the rest of the system. When you have a solar thermal system, you have to store all that energy because you can't use it as quick as you make it. So what you do is you have tanks. In this case, I have a 120-gallon tank made by Rheem, and I have 3 of them. There's one here, and you'll see there's 2 other at the other location. This is the primary tank, and the hot water is diverted after it goes to the heat exchanger over here to what is known as a 3-way valve. This is a motorized 3-way valve. The 3-way valve checks the temperature of the water through an aquastat, which is right here, and when the temperature of this tank is below a certain set temperature, it sends all the hot water to heat this tank. Once this tank is satisfied, and I think right now I have it set at 130 degrees, the 3-way valve is activated, the lever will turn, and the rest of the hot water is now diverted to the other 2 tanks, which are about 15 feet away. Over in this area right here, this is a multi-fuel boiler. It's conventional oil burner, has a Riello burner. I've had this for 25 years, and I didn't want to change it. They of course make much more efficient boilers to this at this time, but I decided to try to integrate my system so it'll send hot water to this boiler in the wintertime. Over here I have 2 additional tanks. In the summertime they're used for backup hot water, for domestic hot water, and then in the wintertime with some fancy valves and an additional heat exchanger, the hot water in these tanks are sent to the boiler to preheat the hot water for the boiler. The last part of the demonstration is heating the swimming pool here. This is a 20 by 40 foot swimming pool. It's about 28,000 gallons, and I'm able to, if I divert the solar beam's energy into it, I could heat this about 6 degrees per day. And I'll show you some of the mechanisms inside. Over here, this is traditional pool plumbing, but in the corner here, I've installed a heat exchanger that is titanium, so it can handle any type of liquids. And as you can see, I don't have it turned on right now, but when the tanks inside the home reach their temperature set point, which I have at about 160 degrees, it will divert. It'll turn on, the valve a sensor will turn on this heat exchanger, and I have a separate pump over here, and then we'll be heating the pool water. Or I can, if I know I'm going to have a party, I can just turn on the exchanger and heat the pool up. Again, I could probably heat at about 5 to 6 degrees per day. Go ahead. As you can see, we're taking a look from the house towards the solar beam. And the most important thing, and I've had to clear a few tops of some trees, is the solar beam must have access to probably, there's no exact science, but figure from an hour after sunrise to an hour before sunset, it should have view of the sky. If you have much less than that, you'd have to consider whether the extra expense of the solar beam would be worth the installation. But you really should have, you know, an hour after sunrise to an hour before sunset of direct access to the sky. So that is about it today. We've gone over a very brief introduction to the solar beam. The cost to install a solar beam could range probably from a low of $30,000 to $35,000 for a very basic system, and of course the average cost is more like $45,000 to $50,000 fully installed. The solar beam is primarily going to be used on commercial buildings, car washes, hotels, bottling plants, anyone that has a large need for solar thermal hot water. I forgot to mention that the solar beam, in a few months, hopefully, they're working on it's called a triple junction PV electric component to the solar beam, in which case you'll be able to make electricity up to 4.5 kilowatts of electricity at the same time that is producing hot water. There will be, of course, a slight hot water reduction from maybe 42,000 BTUs per hour down to about maybe 28,000 BTUs per hour because of the photocells, but you'll be able to get electricity, and I've made provisions for that. I have a separate conduit that runs through the ground. But anyway, that's a brief introduction. please feel free to visit my website, www.solarbeam.us. That's SOLARBEAM.us. Thank you very much.